It was very symmetrical. Alkenes, no accumulation of charges anywhere. Okay. And what happened in CO? Actually, the pi bond is like this. It is more pulled toward the oxygen. Oxygen being more electronegative. The electron density is more towards the oxygen. Okay, the carbon is actually having the partial positive charge. How was your school exam?
Yes, it was good.
And what all topics came in those?
So haloalkanes and haloarenes, alcohols and phenols.
Yeah.
There was electrochemistry and chemical kinetics as well.
Okay. So this is polar pi bond, right? So polar pi bond, because the pi bond is shifted towards oxygen, oxygen being more electronegative, right?
Yes.
It is polar, and that's why the nucleophile, which is an electron-rich species, it can come and get attached to the positive end of the dipole. But there is one problem, that the carbon can make only 4 bonds, that we know. If someone is coming and joining itself to the carbon, we need to push aside that pi bond. Okay. Like this. So nucleophilic addition reactions, because we are not, and finally what we do, we take some water in acidic, slightly acidic medium, not much. So that will protonate this OH. So effectively what you have done, you have added a nucleophile, you have added an H. Okay, means to you have added, you have removed the pi bond and you have added this H and nucleophile. But nucleophile itself has caused this addition, right? So nucleophilic addition reaction, which is the most common. And another thing is, suppose if you have a strong nucleophile, this is going to form very easily. But in case if you are having a weak nucleophile, then what happens? It is going to become reverse. Is it clear?
Yes, sir.
So strong and weak nucleophile will control the extent, okay, of equilibrium. How much is it going to be add, okay, or not? Clear? So another thing is, so what are the examples of these nucleophilic additions? Any example you know from your side, which we discussed in aldehyde in alcohol preparation? Any idea?
So examples of nucleophiles.
Yeah, nucleophiles and nucleophilic addition. Some of them we discussed in alcohol chapter.
So OH.
Yeah, OH, that right. Addition of Grignard we did.
Yes, sir.
Yeah, okay. So that is nucleophilic addition. So addition of alcohol, addition of water, but water is a very weak nucleophile, so it is not going to add. So addition of alcohol, addition of HCl.
Sodium.
Yeah, sodium, just it is going to stay with the negative. Okay. Addition of Actually, what you can do is you can bring in the H later on. So NaCN and H plus. Okay, because you can bring in the NaCN and then you can bring in H plus later on. Addition of NaHSO3. This is called sodium bisulfite addition. And how it occurs, which is the attacking atom, that all we need to discuss. Addition of nitrogen compound or ammonia derivatives. Okay, well, these are ammonia derivatives. Addition of Grignard. In this case, the nucleophile is R minus. Okay. Likewise, there are many additions
So
which
AgNO2 and KNO2.
AgNO2, but that, yeah, that is actually itself resonance stabilized. So what happens is oxygen doesn't attack most of the cases. It is reversible, because in that case, then O minus is resonance stabilized, so it will come out again. Because this minus, what happens, it can form double bond and it can push out the nucleophile. Clear? So that may also happen, right? So you don't take nucleophiles which are resonance stabilized, or if you take, actually what happens, they come out. So these are the main standard, though there are many more. Okay, you can make your own nucleophile, some, but it should be reactive enough. Then it can go and attach itself. Okay, and it should form a stable bond. ONO is not going to form a stable bond. Okay, because there is already one OH, and similarly water also you don't add, because if you have two OH groups on one carbon, what happens, the compound formed is not very stable, so it is reversible. Okay, so let's start with addition of hexane, which is the most common one. So what is the product which is going to form if you add hexane to aldehyde and ketone? First of all, we need to discuss this. No need to take hexane directly, take NaCN, because this is being a stronger reagent, it can join more easily. Okay, and finally you will take some acidic medium H plus H2. So it is going to give you OH. So what this product is known as? Look at the groups. There is one OH group, there is one CN group. Yeah, tell me.
Hydroxymethane cyanide.
Yeah, hydroxy and cyano. Correct. So it is known as cyanohydrin formation. Is it clear? The product is known as cyanohydrin, right?
Yes, sir.
And this is reversible because cyanohydrin is a weak nucleophile, so it can come out. This minus can come again and form a double bond and push out the CN minus. So it is, I can write K cyanohydrin formation. K cyanohydrin formation, it is going to be larger for whom? Actually, if the more product is going to form, if the more reactive and aldehyde is, means the product is going to form in major amount, and your K will be larger. Is it clear? Cyanohydrin, if it is going to form more easily, then if the cyanohydrin is going to form with difficulty, means whatever the aldehyde or ketone and the KCN or NaCN which are taken, that they are going to stay as it is. Okay, unreacted. So in that case, the K will be less. So what is the K cyanohydrin formation for HCHO, CH3CHO, acetone? Yeah, tell me. Where the cyanohydrin is going to form more easily, and for that you need to compare the rate of nucleophilic addition. Okay, so where the nucleophilic addition is going to be more, just you tell me first and then I will.
So in the third case, sir,
Which one, on the acetone or on the acetaldehyde?
acetone.
Acetaldehyde, methanol. Reactivity towards nucleophilic addition, right? Why? What are the reasons? What could be the reason for this?
Sir, because CH3 is a bulky group which can prevent the
Yeah,
nucleophile from
yeah,
attacking.
it is. Yeah, it is a bulky group, so it is preventing. And as you are having more and more bulky groups, what is happening? The extent of addition is decreasing. Is it clear?
Yes, sir.
Also, the methyl groups are exerting plus I effect. Inductive, they are electron donating, means they are not electronegative. Okay, so what happens if they are electron pushing groups? They are not electronegative. So what charge they are going to bring, or they are going to increase or decrease on carbonyl C double bond O? Tell
Negative
me.
charge.
Yeah, negative, or it is already positive, so it is going to reduce the positive charge. Is it clear?
Yes, sir.
So what is going to happen? The positive charge is also going to decrease because of the plus I effect, you can write. And the steric hindrance is increasing. So all these factors are actually preventing nucleophile to come and join in over here. Is it clear?
Yes, sir.
Okay. So as you are having more and more bulkier groups, the rate of nucleophilic addition is going to come down. As you are having more and more electron donating groups, okay, then also you are having more and more electron withdrawing groups that they are going to increase, and if electron donating groups are there, they are going to decrease. Okay, is it clear?
Yes, sir.
So that is very important. And what so where the cyanohydrin is going to form very quickly, it is for the formaldehyde, methanol, then for the ethyl, for ethanol, and then for propanol. So I hope this is clear to you, right? Now let me start with another thing. Can you compare the rate of cyanohydrin formation on benzaldehyde and acetaldehyde?
So it will be more for acetaldehyde.
Yeah, it is more for acetaldehyde. This because of the same reason.
Steric hindrance.
Steric hindrance and electronic factor, both. Clear? Because
Yes,
so
sir.
the benzene is very bulky, it is going to it is going to give electrons by resonance to CO, and which in turn will reduce its reactivity. So I hope this is clear to you, right? Now do some questions. So aldehydes are more reactive. Aliphatic aldehydes are more reactive than aliphatic and then aromatic. Okay. Now the next thing is questions.
So the reason would be inductive effect of the benzene group, right?
No, this is plus I and this is plus R, not the inductive. It is the resonance effect. So how you are going to do the resonance in this case? The pi bond is going to get attracted on C double bond. So this is plus R effect, or plus M effect, mesomeric effect. And actually, as you can see over here, this is enriching. This is enriching the CO more extent by giving its pi electrons. Okay. So, and on the other hand, the pH is very bulky, so the rate is going to come down, right?
Yes, sir.
So what are you going to get in this case? This is H plus H2 hydrolysis. Hmm. Tell me, what is A?
So A will be that so oxy compound like with
Hmm.
O minus, and B will be,
Yeah, that O minus is going to take the H plus from the water, OH,
yes,
and this is
that
the
would
sign,
form the,
right?
so this would be the result of B, right?
This is A. Okay, because water is taken, and aqueous medium actually takes the either if it is written H plus, okay, or if it is simply taken because it is taken in water. So this O minus, because in water H plus is being taken and given. So with water also you can take the H. Okay, it is not in solid state. It is there in the water. So with water also you can take that. Okay,
Yes, sir.
H plus. So this is going to be A. And what about your B?
So it will form, I think, ketone.
Actually, this CN group, this is a new reaction that will be used for the preparation of carboxylic acid. Just remember it in this way. CN group actually get hydrolyzed. In the excess of water. And if there are more than one OH group, they are unstable, so water get removed and ultimately you are going to get COH. In your boards, you are going to write H plus H2O complete hydrolysis with excess of water. Okay. So this is going to form CH3, CHOH, COOH, right? And this is a very important compound, biologically very, very important compound. Which compound is this? Can you tell me? Yeah, it's lactic acid. Got the point? What's the
Yes, sir.
IUPAC name? What's the IUPAC name? So lactic acid preparation is asked. It is there in the NCRT also from acetaldehyde. Is it clear? So
Yes, sir.
now the next thing, and how many stereoisomers will be there for the lactic acid? That's a different question.
So the IUPAC is 2 hydroxy propanoic acid, right?
Yeah, 2 hydroxypropanoic acid. Correct. Yeah. So how many isomers are there for the lactic acid? Stereoisomers. Tell me that. There is a
So
chiral carbon. Can you see?
yes, sir.
Chiral carbon,
Yes, sir.
where it is?
So the center one, the 3 degree carbon.
Yeah, the carbon which is connected to OH, COH. Okay, that is the chiral carbon. Right. Okay.
Yes, sir.
Right.
Yes, sir.
So how many stereoisomers will be there? Tell me.
So 4.
How come four? If there is a chiral carbon, how many possibilities are there? What am I writing over here? Not COH actually. CH3, OH, and H. Sorry. Yeah, tell me. What are these two isomers and why I have written
Stereoisomers.
stereoisomers? But what type of stereoisomer? Why I have written them side by side? What's the reason? What kind of stereoisomers are they? Tell me quickly. Yeah. Hmm. These are enantiomers. They are stereoisomers, but the stereoisomers is a very, very huge term. Okay.
Yes, sir.
So they are what? They are enantiomers. Okay. What are enantiomers? Can you tell me?
Enantiomers are compounds which can which do not superimpose on each other
Yeah.
on their mirror image isomer.
Non-superimposable mirror image isomers. Yeah, exactly. Is it clear? So
Yes, sir.
why you have these? Because the carbon actually was was chiral. It was connected to four different groups, and that's why the mirror image which was generated was actually it was having the mirror image was also having the four different groups. But what happened over here is the mirror image actually is now it has become non-superimposable, because if you move from H to CH3 to OH, it is clockwise, and H to CH3 to OH, it is anti-clockwise. Okay,
Yes, sir.
so that is the reason why it has not. They are non-superimposable, and there are two isomers. Okay. So I hope this is clear to you. You can hydrolyze and you can convert it to carboxylic acid. But there are other options also. If you reduce it, the CN will become, it is going to become CH2 NH2 if you do the complete reduction. Okay. So I hope this is clear to you.
Yes, sir.
Other addition is sodium bisulfite addition. Or if you try to compare the rates, and if you try to, how this group is going to affect, can you tell me? This may also come.
Which group, sir?
This group G is going to affect. Suppose if I put NO2 group, or if I put OCH3, where the nucleophilic addition is going to be faster.
In the first case, sir, where there is NO2.
Yeah, because NO2 is going to pull the electron by resonance. So this is going to be more reactive. Okay. But this is going to be less reactive. because the benzene ring, because of the electron donating group, it has become more electron donating. So the reactive is, suppose if the substance is actually getting the electron from internally, then it is not going to react with the nucleophile. Okay. Now the next thing is sodium bisulfite adduct formation. Addition of NHSO3. Okay. So how the NHSO3 is going to get added? Okay, first of all, you should tell me this. What's the name of NHSO3?
Sodium hydrogen sulfate.
Yeah, sodium hydrogen sulfide or sodium bisulfite. Okay, clear?
Yes, sir.
So actually, this H plus is bit acidic, so you can take this H plus out, and its structure is like this: O minus, O minus. Okay, one of them was OH, H plus. Is it clear?
Yes, sir.
But to H plus you removed actually. So H plus actually you remove, and what happened? This one. And there is one more doubt which always been many students are doubtful about this. And this is your aldehyde and ketone. So now this is a nucleophile. You're not going, because this is negatively charged. NaSO3 minus. That is going to add itself to the delta positive of the carbon. Clear? So how is it going to add? Tell me. Hmm.
So by breaking the double bond, I think
Yeah,
oxygen will attack.
yeah, yeah. Oxygen will attack. Most of them will say this, but sulfur, it's the lone pair of sulfur which is going to attack. Clear? That's the main thing. So there is a carbon sulfur bond formation during bisulfite adduct formation. Is it clear? That's the key thing which you should know. Okay. So actually the sulfur it is going to attack, and this sulfur actually is bigger atom, so it can, its lone pair is more loose. On the other hand, O is minus, so that's why it creates confusion. But the O minus is in resonance, so it can't, it is moving, so it just can't attack. Okay, is it clear?
Yes, sir.
SO3 and then H plus is already there. So that's how you're going to get the answer. So this is known as sodium bisulfite adduct, and it is white crystalline solid. Is it clear?
Yes.
So now the thing is, so if the reaction happens, can you make this out how the reaction is happening? Hmm. Can you make out how the reaction is happening? Well, how will you make? How will you know that the reaction is completed? You will see this white crystalline solid being formed.
Yes, sir.
I hope you understood this. Okay.
Yes, sir.
So this is the main reason how the reaction is going to take place. Okay. And you can also use to separate the aldehyde and ketone. And which aldehyde ketone are going to react? That's the main thing. So any idea? Which aldehyde and ketone? Actually, aldehydes are more reactive, we have seen. And ketones are less reactive. Okay, but in ketones, actually only methyl ketones are going to react. Means on if you have a bigger ketone, then the reaction may not happen. Okay, is it clear?
Yes, sir.
So methyl ketones, aldehydes, they are going to form this white crystalline solid. Not the large methyl ketone. You understood now what it means?
Yes, sir.
At least one side you need to have a methyl. Okay, so they can react, and you know how they will react. Actually, once they will react, you will see the white precipitate forming over there. Okay, that's the main thing. Now the next thing is, how will you distinguish 2-pentanone and 3-pentanone? Tell me quickly.
Sir, white crystalline solid will be formed in the case of 2-pentanone, and it will not be in the form of in the case of 3-pentanone.
Exactly, because that is not the methyl ketone, right?
Yes, sir.
So I hope this is clear. And what about if you take CH3CHO and HCHO? Can you separate them?
No, so both will give the same crystalline solid, right?
Yeah,
But
so
I
both
think
will.
for the second case, it will give more, I guess.
Yeah, but ultimately both will form.
Okay, sir.
Okay, so ultimately both will form. So what is going to happen means you are not going to use this for separation. Okay,
So
because
reaction will be more faster in formaldehyde, right?
yeah, both will react more or less. But the PPT actually, if you are having this PPT together, you can't get the product separated, one product separated out of the other, because both will ultimately form the precipitate. So this reagent cannot be used to distinguish between these two, because both of them form the PPT. But the upper one you can have. Clear?
Yes, sir.
So I hope this is clear to you, right? Okay, clear.
Yes, sir.
So this is a very important test, okay, to distinguish. Now the next one is addition of alcohols. Addition of alcohols on aldehydes and ketones. So first of all, tell me what you are going to get if you add alcohol. That's also a big problem, because most of the students are not able to tell what the product is going to be. So first of all, try to form the product. Suppose if you have an aldehyde or a ketone, and if you add alcohol, so alcohol is ROH. Okay. So where should I put H and where should I put OR? Tell me. Yeah,
Sir, OR will go to the carbon and H will be there. It should be on the ox.
because this is plus and this is minus. Okay. And H is plus. Okay. And O is minus OR, and this is how the addition is going to take place. You break this bond, you break this bond, and you connect them. So what you are going to get? OH and OR. Right. Very good. But you need some catalyst to make it more reactive. You take dry HCl. Don't take aqueous HCl. Suppose if you take aqueous HCl, then what is going to happen? It is going to break apart again. It is going to hydrolyze, and then again the OH are going to come. And again, you are going to have that ketone back. Is it clear?
Yes, sir.
So now the problem is, what's the name of this product? So the product, suppose I will tell you the quick trick. Suppose if this is LDI, the product is going to be called as acetal. Okay. And if there is one OH and one OR, that is hemiacetal. But suppose if you react an aldehyde with two alcohol molecules, then the water is going to get removed. And this is going to be complete acetal. Is it clear? You need to take dry HCl because if you take aqueous HCl, your product is going to break. And again, you will get the aldehydes and your alcohols back. Right? So I hope
Yes,
you
sir.
understood. And what happens if you have a ketone? Ketone actually don't react very quickly. Why ketone don't react very quickly? What's the reason? Because ketones are less reactive towards nucleophilic addition reaction. Why they are less reactive toward nucleophilic addition reaction?
There's no presence of hydrogen next to them.
Yeah, because they are both alkyl groups and which are bulky. That's the reason. Because of their bulky nature. Okay.
Yes, sir.
So if you are going to take dry HCl, what you are going to do? Remove the water. Okay. And if you take 1 mole, then it is hemiketal. There will be one OH. I will write here 2 moles. And with 1 mole of ethanol, what you are going to get? Tell me. What should I write here at these positions? Yeah.
OH
Is
and
what?
OR.
OH and yeah, exactly. So one is going to be OH and what is going to be OR? R is the ethyl group. Okay, so this was ketone. So the product will be known as what? Tell me. What will be the product known as? Is it a ketal? For aldehydes, it was acetal. Okay, for ketone, it was ketal. But my question is it hemiketal or ketal, complete ketal?
So it will be
Understood?
complete ketal.
Yeah. What I'm trying to ask, if there is one OH, if you add 1 mole of alcohol, it is always going to be hemi. Okay. Like in the above case, there was one OH and one ether group, so it was hemi. If you have two ether groups, it is not hemi, but whether it is acetal or ketal, that you can tell by the from the starting material, whether you started from aldehyde or whether you started from ketone. Is it clear?
Yes,
So
sir.
tell me what's
So
going to
heavy
be done.
ketal.
This is hemi ketal, right? And what about the upper one?
Ketal.
Yeah, this is ketal. So I'm not going to put OH, I'm going to put OCH2CH3. This is ketal and this is heavy ketal. And get your you can get your cyclohexanone back. How can you get them back? Just put dilute HCl. This will hydrolyze dilute HCl will break this again and OH water will get removed and you will again get your ketone back. But in ketones, what is more famous is Actually, because the ketones are less reactive, so instead of choosing two alcohols, 2 moles of alcohol, what you do? You very intelligently choose one diol. Okay. The reaction is same, but it is going to be more easy because now the molecule is only one molecule, but that one molecule is having two H groups. So the reaction is exactly same, but now it's going to be more easier to take place. I hope it is clear. So this is cyclic ketone, right?
So why will it be more easier?
Actually, what happens if the more molecules combine together, there is more going to be entropy drop. Is it clear? You know entropy drop delta G, delta H minus TTS. You remember that from 11th class?
Yes, sir.
Okay. So in the above case, 3 molecules were combining together, right? And so there was more entropy drop happening. Okay.
Yes, sir.
And now only 2 molecules, the reaction is same, but 2 molecules are combining together, so it can occur more easily. I hope this is clear to you.
Yes, sir.
Okay. So this is cyclic ketone. And these are actually acting as a protecting group for aldehyde and ketone. Suppose if you don't want to react your aldehyde or a ketone to aldehyde or a ketone, you don't want to react it in nucleophilic addition reaction. Suppose if you don't want Grignard to react with aldehyde or a ketone, what you can do, you can you can just convert them to acetal or ketal. Okay, and acetal and ketal are those cyclic ethers, so they will not react. Clear?
Yes, sir.
So there was a question actually in JEE advanced. So the functional group which is present in A is acetal, hemiacetal, is it ketal or hemiketal? This was asked in JEE advanced. Tell me. Actually, most students find this difficult.
So I think
First
hemi
of all, you need
acetal.
to check is there any OH connected? if there is any OH connected to carbon on which the ether is connected. Then you can tell hemi. Otherwise, skip the word hemi. Clear?
Yes, sir. And so it's keto, I think.
Okay. So hemi, B and D are rejected. Now the question comes to whether it is acetal or ketal. So you need to think whether this is having this carbon 2 is both are connected. That was a ketone or an aldehyde prior to forming this. Yeah, was it a ketone or was it an aldehyde? So ketone actually, I will tell you. You also know very well. Ketone CO2 carbon groups are connected. On aldehyde, only one carbon group is connected. At least one, or one should be hydrogen. That you know now very well.
Yes,
Now
sir.
tell me. Yeah, now tell me. Are there two carbon atoms, or is there one carbon atom, one hydrogen? So
So
now
one
think,
carbon.
yeah, one carbon, one hydrogen. So now think in terms of that whether it was ketone prior to forming this cyclic structure, or was it an aldehyde prior to forming this cyclic structure? What was it?
So acetone.
Yeah, it was aldehyde earlier because there is one H. If you have two carbon, then there is no possibility. Okay, you can check it. There are two carbon atoms. Okay, is it clear?
Yes, sir.
So now what should be the answer? A, B, C, or D?
A, sir.
A. Okay. So remember this and very useful thing. This was the question from JEE Advanced, right? And you need to distinguish. And the thing is, suppose if this is what is it? Acetal, ketal.
So hemiacetal.
Yeah, this is MEA-acetal. Correct. This is ketal. So what am I going to get if I react it with aqueous HCl?
So phenol.
No, phenol need to have that benzene kind of structure. The ring is there, but that double bonds are not. So do the hydrolysis, that's it. If you have aqueous, do the hydrolysis, break it like this. And you have one OH on two carbon atom. Two OH on one carbon atom, and those are unstable, so water is going to get removed. Okay. So double bond O, water is going to get removed and two methanol molecules. That's how we are going to get it. Okay.
Yes, sir.
So this, I hope you understood this. Now the next reaction is reaction with ammonia derivatives. When will be your final board examination?
So I'm not sure. I think around February or March.
Yeah, and date as it will be announced very soon. So now the reaction with NH2Z, ammonia derivative. The reaction is very simple. Reaction or addition of why it is called ammonia derivative, because ammonia is NH3 and if you remove one H and if you put one Z, it becomes something derived from ammonia, so it is ammonia derivative. Okay. So reaction is very simple to do. Just remove water. Right?
Yes, sir.
Just remove water and form double bond. And this compound, depending upon the Z, it will have certain name and accordingly the name of the product will be written. Okay. Suppose if this Z is alkyl group. So this is primary amine. Okay. And what the product will look like, it is known as amine. Okay. Let's remove water. Right. What will be the name of the reactant if you have OH as Z? What's the name of this reactant? Tell me. This is hydroxylamine.
Yes, sir.
Okay. Hydroxylamine is NH2OH. And what you are going to get the as your final answer? You are going to remove the water. Okay. Then you are going to get C double bond NOH. This is known as oxime. Very, very important. Ox and IME. Okay. Oxime. Right? Oxime. If you have hydroxylamine, the product is going to be. You need to know the name also in the boards also there given, so it is very very important for you. And suppose if you have two NH2 groups connected to one another, then Then it is what? What's the name of this compound? Hydrazine. Okay. And what's the name of the product? This is known as this functional group N single bond N double bond carbon is known as hydrazone. Because hydrazine has reacted with ketone or double bond or so hydrazone. Okay. What's the name of this product? I have attached one group on hydrazine. Just need to add the name of that group on hydrazine. You can tell me the name of the product. Yeah, tell me.
So benzohydrazine.
Yeah. Phenyl hydrazine. Right?
Yes, sir.
And water is going to get removed. What you are going to get over here? This is the upper one was hydrazone. This is phenyl hydrazine. What about this one? This is also you can add something to the name which was written above. Yeah,
Dinitrophenylhydrazine.
yeah, dinitro. Yeah, exactly. So this is 2,4. The short form is it's very famous, most famous 2,4-DNP shortcut. It is also known by the name of Brady's reagent, which is a less common name. And the product is going to be 2,4-dinitro. Clear?
Yes.
So actually, why this is so important? The products are bright, bright yellow, orange, red color crystalline solids. Okay, so this is used to test aldehydes ketone as a whole, not among themselves, whether it is not whether it is aldehyde or whether it is ketone, but aldehyde ketone from rest of the other functional. Okay, is it clear?
Yes, sir.
So for example, if we say there is a compound A whose formula is C5H12O. Upon oxidation with PCC, it gives B, which is C5H10O. It is a symmetrical diketone. Okay. What is going to happen if you react it with yeah, tell me. Understood the question?
Yes, sir.
Yeah. So what's going to be the answer over here? Upon reaction with NHSO3. So what is that symmetrical diketone should be of 5 carbon atom? Yeah.
So white crystalline will not be produced in the
Will it be
NaHSO3.
formed or will it not be
No,
formed?
no, sir, it will not be.
Why?
So because it is ketone.
Yeah, it is a ketone and not methyl ketone.
Yes, sir.
Symmetrical means if there are 5 carbon atom, you can have only one structure which is possible. This one. The ketone could be this also, but this is not a symmetrical. Clear?
Yes, sir.
So it is not going to give you. And what about what you are going to get if you react it with 2,4-DNP? What's the product? So all aldehyde and ketone give this test. So remove water O and H2 from NH. Is it clear?
Yes, sir.
And that's how we are going to write the product. And this is bright colored. The color can be orange, red, yellow, brown. Okay, these it depends upon some groups, okay, which are present. So I'm giving you the general idea, okay, how the color should be. Clear? So generally these are bright colored crystal solids, right?
Yes, sir.
And suppose if it is not aldehyde, suppose if I tell, suppose a compound is there, it doesn't form any bright colored compound. But upon reaction with excess HI, it gives this. So which compound is this? What's the structure of A? Tell me.
So I think option A.
Yeah, option A. It can't be B, it can't be C, or it can't be D. Is it clear?
Yes, sir.
So the formula is matching with C and formula is matching with D also. C5H10O. But actually the product is not so product is not matching when you react with 2,4-DNP. If it is, if you suppose if it is B, C, or D, then it should react with 2,4-DNP and give some bright colored compound. But it is not reacting, means it is not an aldehyde or a ketone. Okay. But it is reacting with HI excess. So which reaction is this? Where we have studied this reaction. Any idea? Yeah, where have we studied this reaction?
So I think it's in the Halloran's chapter.
Yeah, in the ether. Ether, we cleaved ether with HI. Remember? ROR with HI, ROH plus RI. And if you take HI excess,
Yes, sir.
okay, water is going to come out and add it. So it is the reaction of the ether. Clear? So this is used to test the aldehyde ketone as a whole. And there is one more. Just go through them in NCRT. Just I will write it very quickly because we are running out of time. This is semi carbazide. Okay, semi carbazide, and the product is going to be this and you are going to react not this one or this one because they are in resonance. So their lone pair is not going to come and join. The product is semi carbazone. But this is also one of the same series of reaction which we written. Uh, just write it. Okay, just go through them.